Rational zero theorem, okay? So our rational zero theorem is what you need to do your polynomial showdown, okay? It says, if a polynomial equation has integer coefficients, then any rational zero must be in the form of plus or minus p over q, okay? Where p is the factor of the constant term and q is the factors of your leading coefficient. So when we look right here, this is our p, this is our q. Now, whoever created this rule, why did they put it in that order? Why did they not put P then Q? I don't know. Have no clue. I get asked that, and I keep telling myself, well, maybe one day I'll find out why, but I have yet to do that. So your factors of 3 are 3 and 1, right? Your factors of 2 are 2 and 1. Okay, to find your possible real zeros, it's a combination of P divided by Q. And it's their positive and negative results. Okay, so basically you have 3 divided by 2, which is 3 halves. You have 3 divided by 1, which is 3. You have 1 divided by 2, which is 1 half. And then you have 1 divided by 1, which is 1. So that means you have a possible 8 real zeros. So these are your 8 options for which one is the real zero that would work for that. Okay, what do we mean by real zero? Is that if I am trying to find this without a calculator, finding my zeros, I can use synthetic division to break this down to a quadratic, then use the quadratic formula. Does that make sense? But I have to figure out which one of these numbers will work for my synthetic division. And by working it gives me a remainder of 0. That's how you know it works. Okay, we're going to model it, but I just want to make sure we can do this part. Okay, can you find the factors of a single number? And then can you divide? That's part number 1. Okay, so we're going to try it. Ready? So again, backwards, not PQ, but QP, Q and P. And it's going to be P divided by Q. Okay. So first we're going to list out the factors of our 2. What are the factors of 2? What numbers evenly divide into 2? 2 and 1, right? Agreed? Now we're going to do 10. What numbers evenly divide into 10? 1, 2, 5, and 10, right? Yes. Okay. So that means our possible, keyword here is, our possible roots are P over Q. So first P, we have 2 over 1. Okay, then we're going to do 2 over 2. Then we have 2 over 5. And then we have 2 over 10. The goal is to be able to reduce as you're doing it. For learning purposes, I'm not reducing. Does that make sense? So I took my first factor and divided it by each one of its factors. Do we see that? Now I'm going to do it again with my second factor. So now I'm doing 1. So 1 over 1 is going to be 1. 1 over 2. 1 over 5. And 1 over 10. Okay, and it's the plus or minus of all of these. So plus or minus all. Now we want to simplify and only write the simplified form. So 2 over 1 is 2, right? 2 over 2 is 1. 2/5, can I simplify that anymore? Nope. 2/10 is 1/5. 1 over 1 is 1, already done. 1/2. 1/5 we already have. And 1/10. So these right here represent my possible 12 zeros to test out. And that would be your answer. So on your discussion post for your polynomial show-off, this is the first thing you have to do, is find all the possibles. Okay, do you think we can do that? Yeah? All right, now we're gonna talk about applying the possibles. So again, the purpose of the possible is to help us reduce this. Thought I had it applied. Oh, let me add a slide. Resume. All right, so now we're going to just practice applying this. So the purpose of these slides is so that we now have options to use numbers we can use for synthetic division. We have to figure out which one works for our problem. Now, we made sure that we were comfortable with synthetic division, so here we go. All right. So the goal with synthetic division is for it to equal remainder of 0, okay? You remember vertically we multiply, diagonally we multiply, vertically we add. Doom, 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 okay? So the first thing is you're gonna decide which one of these do we wanna test? Which number? We're gonna do one, positive one or negative one? All right, we're gonna test negative one. So I'm gonna set it up. I have negative 10, negative 17, 7 and 2.
And it'll work with any of the numbers.
And you got to figure out which one works. These are your possibles. Exactly. All right. So remember, diagonally we multiply. So negative 1 times negative 10 is positive 10. Vertically we add. Negative 17 plus 10 is negative 7. Negative 1 times negative 7 is 7. 7 plus 7 is negative 1 times 14 is, and we end up with negative 12. Is it 0? Nope. So that means negative 1 is not a real 0. Okay? All right. What I'm going to challenge you is you're going to choose a number. So we already know that negative 1 does not work. Well, I didn't mean to cross out the whole thing. Just cross out the negative. Huh? No, I'm going to have you challenge. Okay, so the negative didn't work. Okay. I want you to pick one of these numbers and you're going to see which one works or try. So we know that negative 1 doesn't work. It's best if everyone doesn't do the same number. So who wants to test out positive 2 for us?
I'm doing that.
Oh,
I'll do negative 2.
okay. So America has positive 2 and Lupe has negative 2. Anyone wants to test out positive 1 for us? Katie got positive 1. Okay, we're into the fractions, and fractions are our friends. You're gonna, You're gonna do positive 2/5, see what happens? And Johnny. Gonna try? Okay, then try 2 at least. So do the whole number then. Yeah. All right. All right, so after everyone tested out, we find out that negative 2 is the one that gives us a 0. So what it looks like, if I have negative 2, right? That's going to be negative 10, negative 17, 7 and 2. I bring down my negative 10 to get it going. Negative 2 times negative 10 is 20. Negative 17 plus 20 is 3. Negative 2 times 3 is negative 10. I said negative 6. And y'all were just going, that's not math. I just rewrote what I saw. Negative 6. 7 minus 6 is 1. Negative 2 times 1 is, and this gives us 0. So that means that when we divide out x minus 2, we're left with negative 10x squared plus 3x plus 3x plus 1. There is not one. Yeah, it's a unfortunate situation, y'all. Okay, so now, so the factor, this is not fully factored, but we know that our factors are x plus 2, because what worked? -2, correct? Now, to find our last factors, we would either use the quadratic formula or Xbox or any other method you've learned to factor, okay? If you're not strong at factoring, then the quadratic formula is going to always be your friend. X equals -b plus or minus the square root of b squared minus 4ac divided by 2a, okay? If you're not strong at factoring, then the quadratic formula is your friend. If you are strong at factoring, we'd learn how to do Xbox, right? So I'd ask myself what multiplies to give me -10, but adds to give me 3. Does that ring a bell? Anybody? So for Xbox, we multiply a times c, and that's -10x squared. And we want it to equal our b, which is 3x. So what multiplies to give me -10 x squared, but adds to give me 3x? A 5 and a -2. So 5x and -2x. Agree? Okay. So once you're here, you have a couple of options. I saw this pretty cool thing that where they just turned this into the box, but it didn't make sense. So I was like, I'm not doing that. So you can either do this by grouping or by the box. If you're a visual learner, the box is your best friend. So the box allows for you to visually see where everything falls. Okay. In the box, it's always the top. So you have -10x squared. And then your first term and your last term. My last term is 1. And then your magic numbers from your x, which are 5x and -2x. The purpose of the box is to help you find your greatest common factor faster. What is the GCF between these two?
2.
Not just 2, but a -2. What is the GCF between these two? 1. GCF between these two? It's going to be a -5. If the outer box is negative, the GCF is negative. Okay. And then here, a negative. So your factors are what comes out of the box. So now you have the rest of your factors. Does that make sense? So the rest of your factors are -2x plus 1 and -5x minus 1. And that's this fully factored. Now, on your test with me, I will take this. Pearson will not take your leading term being negative. And because of that, you have to factor out the negative. I will take your leading term being negative. However, Pearson will not. And therefore, you have to factor that out. So this and non-negative will be -2x minus 1. Does that make sense? This one would be times -5x plus 1. But what happens here? A negative times a negative makes a positive. So your negatives are going to cancel out. This is what your final answer is. X plus 2 times 2x minus 1 times 5x plus 1. That is it in fully factored form. How do you test it? Anyone? You multiply, right? You would remultiply. And you're like, oh, yeah, I did it. Or no, I messed up somewhere. Okay? That's how you do it. You'd have to multiply it out. Okay? I messed up somewhere, though, because I need a negative in the front. I can tell you that much. I should have factored out the negative to begin with. That's why. All right, let's try another one. We're going to go from beginning to end. Oh, this is when we don't have to do that. This is easy. This is practice quadratic formula. Easy. Yes. All right. A lot of times when we learn something hard, we think we have to automatically always do the hard stuff, right? No. If we stick to our number one rule, check for GCF, this becomes actually fairly easy. Is there a GCF? Yes. What is it? X. So if I factor out X, I'm left with X squared plus 6X minus 7. And this is a mental math. I asked myself what multiplies to give me -7, but adds to give me 6. 7 and -1. So my factors are x minus 7 and x plus 1. I wrote that backwards, y'all, and no one said anything to me. I guess I could have just put a line through that one. There we go. So double checking, 7 minus 1 is 6. 7 times -1 is -7. So this is my factored form. How do I find my zeros? It's inverse pretty much, but you're saying mathematically, what are you doing? You're setting each factor equal to 0. So x equals 0, done. There's my 0. I have x plus 7 equals 0. So what is my x? -7. And then I have x minus 1 equals 0. So what is my x? 1. So I found all of my solutions. On this one. Huh? Yeah. Okay. All right. Here we go. Now we have 9x to the 4th plus 23x squared minus 12. This is a special case quadratic. The reason why we call it a special, I call it a special quadratic. So I call this a special quadratic. And it's not really a quadratic, but it can be mimicked as a quadratic. Okay. How do I know that? It's because when you look at your powers, it is in the same pattern of a quadratic. So our quadratic is ax squared plus bx plus c, right? Notice the powers are 2 and 1, and then no power. Okay. Anytime that the power of your leading term and the power of the second leading term are half of each other, you can treat it like a quadratic. And that's because that middle term is going to add to create it, as long as it's half. So like if I had ax to the 6th plus bx to the 3rd plus c, notice that the power here is half of that power. And therefore, I can do the same thing that I do with a quadratic with this function. Does that make sense?
You can just put this in like in a graph or something.
If it's on the graphing part of your test. But
Why can't you just put it instead of solving?
But what if it's not on the graphing part of your test? Ugh, I know. Darn it. Okay. All right. So what happens here is that means everything that I can do with a quadratic, I can do with this function. Okay. I can factor it using Xbox. I can factor it. You can use the quadratic formula. Whatever I can do with the quadratic, I can do with this. The only difference is that instead of my factors being x plus or minus something, it's now going to be whatever x squared plus or minus something. Okay. All right. So we're going to practice the quadratic formula. That's the x equals -b plus or minus the square root of b squared minus 4ac divided by 2a. What that looks like is negative. This is your a, this is your b, this is your c. So we have -23 plus or minus the square root of 23 squared minus 4 times 9 times -12. All over 2 times 9. Okay. For this test, when we take our test in a week or so, you'll have 2 calculators. So you'll have a basic calculator that's a non-graphing calculator for the non-calculator part of the test, and you will have a graphing calculator that you can use for the calculator part of the test. Does that make sense? That's because the focus isn't can you multiply, right? The focus is can you set up the quadratic formula and use it correctly. Okay, so I don't want a hiccup for you to be I don't know how to multiply, miss. That's okay. So I'm going to just pull out my basic calculator. Open this little guy here. Here's my basic calculator. and I'm looking for 23 squared. That's gonna give me 529. I have negative 23 plus or minus 529. I really do need an undo button on this page.
I just gotta remember that one.
If you're not strong at factoring, it's gonna be your best friend. Okay? Now I'm gonna do my 4 times 9. So 4. Well,
Is it DX3 or is it DX?
let me see. I gotta look and see what you're talking about. And that's gonna equal 432. So I had 529 and 432. A negative times a negative made this into a positive. So I'm just gonna go ahead and add plus 529. Enter, and I get 961. So this was 432 over 18. Keep going. So get negative 23 plus or minus, what did I say, guys? 961?
Yeah.
961. And now we need the square root of the 961. Only thing I don't like about this one is that will not. It refuses to stay up on the screen. And I get 31. So we end up with negative 23 plus or minus 31 divided by 18.
Do you leave it like that or just pull this off?
It means you solve. So this means that you're going to do negative 23 plus 31 and divide by 18. Then you're going to do negative 23 minus 31 and divide by 18. What is negative 23 plus 31? For someone?
8.
8. What's 8 divided by 18?
4 over 9.
4/9. So we get x equals 4 over 9. What's negative 23 plus 30? Well, minus 31. Negative 54. And what's negative 54 over 18?
3. Is that right? 3.
Dang, I missed my.
So x equals 3. So these are my two solutions.
Is it negative?
Oh, yes. Thank you. So we get x equals 4/9 and x equals negative 3. Okay, so that means when I graph this, it would be at both locations.
Can I stay here? I'm just gonna go look again.
What is it? Are we at lunch? Are we at lunch? Is it lunchtime?
Yeah.
I'm
Like,
Push.
you know,